Yesterday, we saw turbine blades that survive temperatures hotter than lava. Today we ask, what controls them? 25,000 moving parts. Spinning at 10,000 RPM. Operating at 1,700 degrees. One mistake. One miscalculation. One software bug. And the engine explodes. So what keeps it all in perfect harmony? What prevents the turbine from overspeeding? What stops the fuel from igniting at the wrong moment? The answer isn't mechanical, it's digital. A modern airliner has over 1,000 computers. Not one, 1,000. They're called LRUs, line replaceable units. Each one is a specialized computer controlling a specific system. The most critical is the FADEC, Full Authority Digital Engine Control. This is the brain of the engine. It monitors 5,000 parameters per second: temperature, pressure, RPM, vibration, fuel flow. If any parameter exceeds limits, the FADEC reacts in 50 milliseconds. Faster than a human blink, faster than you can snap your fingers. But here's the impossible part. This computer must survive what would kill a normal laptop. Temperatures from -55 to +125 degrees Celsius. Vibration up to 20 Gs. Electromagnetic interference from radar, radio, and lightning. A normal computer would crash, would freeze, would fail. The FADEC doesn't, because it's built like nothing you've ever seen. In segment 2, we'll see the triple redundant processors that never disagree, and the programming language designed to prevent death. Inside the FADEC are 3 identical processors. Triple redundancy. They run the same code. They process the same data. They compare results 100 times per second. If one processor disagrees with the other 2, it's shut down. The system continues with 2. If another fails, the last one keeps the engine running. This isn't backup. This is survival engineering. But hardware isn't enough. The software must be perfect. Not mostly perfect. Not good enough. Perfect. The code is written in ADA, a programming language designed specifically for safety-critical systems. Created by the US Department of Defense. Used in aircraft, missiles, nuclear reactors, ADA forces programmers to declare every variable. To handle every error. To prove every function works before it runs. The FADEC software has 500,000 lines of code. To put that in perspective, the space shuttle had 400,000 lines. But writing the code is the easy part. Testing it is the nightmare. Each function is tested 10,000 times. Simulating every possible failure. Sensor disconnect. Power loss. Software crash. Cosmic ray hitting a memory chip. The system must handle every scenario without catastrophic failure. Testing takes longer than writing. 5 years to prove the software won't kill people. The documentation is 50,000 pages. If printed, it would fill a small room. But even perfect code running on perfect hardware can fail, because the environment is hostile. In segment 3, we'll see the electromagnetic storms that threaten to crash these computers, and the shielding that keeps them alive. The FADEC is sealed in a titanium case, not for strength, for shielding. Inside an aircraft, electromagnetic interference is everywhere. Radar pulses, radio transmissions, lightning strikes. Even the engine's own ignition system generates electrical noise. This noise can corrupt data, flip bits in memory, cause a computer to execute the wrong instruction. In a normal device, a bit flip might cause a glitch, a frozen screen, a restart. In the FADEC, a bit flip could command the engine to overspeed, to cut fuel, to shut down. So every wire is shielded, every connection is filtered, every circuit is protected. The titanium case acts as a Faraday cage, blocking external electromagnetic fields. Internal circuits are separated by ground planes. Signals are differential, so noise affects both wires equally and cancels out, but shielding isn't enough. The computer must also survive temperature extremes. -55 degrees, the cold of the stratosphere, plus 125 degrees. The heat near the engine, electronic components expand and contract with temperature. Solder joints crack, connections loosen, chips fail. So every component is qualified for the full temperature range. Every connection is tested for thermal cycling. Every board is coated with conformal coating, a protective layer that prevents moisture and corrosion and vibration. 20 Gs of vibration. Enough to shake loose any normal connection. Every connector is locked. Every screw is torqued to specification. Every component is glued in place. But even with all this protection, the FADEC can still fail. Not from hardware, not from software, from something more subtle. In the final segment, we'll see the certification process that proves these computers won't kill people, and the staggering truth about what it takes to trust code with your life. How do you prove software won't kill people? You don't just test it, you certify it. The FADEC must meet DO 178C, the international standard for safety-critical software. Level A, the highest level, for systems whose failure would cause catastrophic loss of life. Level A requires every line of code traced to a requirement. Every requirement verified by testing. Every test documented. Every decision reviewed by independent engineers. The certification process takes 5 years. 5 years to prove the software won't kill people. The documentation is 50,000 pages. If printed, it would fill a small room. Every change, every test, every review is recorded. And it's not just the FADEC. Every computer on the aircraft must be certified. 1,000 computers. 1,000 certifications. The cost isn't just time, it's money. Developing and certifying the FADEC software costs over $100 million. But the price isn't just money, it's trust. When you board a plane, you trust that 1,000 computers are working perfectly. That 500,000 lines of code won't fail. That triple redundant processors will catch every error. You trust that 50,000 pages of documentation stand between you and catastrophe and your right to trust. Because the system is designed to fail safely. If one computer fails, 2 remain. If 2 fail, 1 keeps flying. If all fail, the engine defaults to a safe mode. The FADEC doesn't just control the engine. It protects you from itself. This is how the impossible is built. At Dark Whisper, we reveal the machines that keep you alive. Tomorrow, we follow the wiring that connects 1,000 computers. 200 miles of cable, 15,000 individual wires. Subscribe to see the full series. I'm Lucas, and I'll see you in the next investigation.